serving our application at that point. That's what makes it live. The service that we use as sort of a middleman between our computer and the deployment system is GitLab. So you guys have seen GitHub. GitLab is essentially just another flavor of GitHub. It still uses Git's software to connect to and to make repos. But the beauty of GitLab is that you can create private repositories for free. GitHub charges you. Again, we don't want any of these exams online, and GitHub is completely public, right? Again, if you guys do find an exam online, run away as fast as you can, right? Don't be tempted to use that code, because I will know, we will all know if we use that code, and that's an automatic disqualification, and you have to retake Python. We could technically kick you out, but I don't think that, I don't want to do that, but I would definitely make you retake Python. So don't cheat. But when you do deploy, this is actually going to be different instructions than what's on the platform, because the platform will tell you to use GitHub. We're going to be using GitLab and making sure we do a private repository. Cool? AWS, set it up today. Everyone, set it up today. It can take up to 24 hours to activate. Realistically, it takes about an hour, but set it up just in case. And if for whatever reason, if you set it up today and it's not activated tomorrow, talk to me. We'll figure something out, right? But set it up today. Cool? All right. So, housekeeping out of the way, what we're going to do is we're essentially going to set up our application to be served. So these first couple slides kind of talk to you about, again, what a server is, how a server serves up our application. Talk to you about process managers and how we set up something called gUnicorn to essentially keep our application running. It'll also talk to you about Nginx and how we set up essentially a web server, because we talked about the difference between a web server and a logic unit. The web server is really just what handles all the requests coming in and communicates with the logic unit, and essentially the logic unit understands the request and understands what it should do. So the development web server that exists for Django, it works well for dev, but at the end of the day we want to swap it out with something that's a bit more robust. So with Nginx and gUnicorn, we implement these two services to be a more robust system to handle the requests that are coming in. So Nginx can handle something like 10,000 requests or something wild. Flask, I think, could handle 2, right? So the built-in web servers are not production ready, right? So we swap those out, and they keep our application running as well. So read that information when you guys do have time, but for time's sake, we're just going to hop into the setup. And this section is really just devoted to kind of getting us to set up our project properly to be deployed. So I'm going to navigate to the record headers, which is where my application was, right? My project folder. Well, actually, before that, I'll need to make sure I activate my environment, because we want to make sure that when I run pip list, I get only these specific packages that I need for this project. You open yourself up to errors if you had a bunch of garbage packages in there that maybe you were doing some machine learning, maybe you're doing something else. You have packages that might not work on the system that we're going to deploy to. These are the packages that we will install on that system, the ones that we know work for our application. So that's why it was so important to use virtual environments this whole time. So we can keep these parceled up as this group of technologies that I know for sure will work and will work on the deployed system as well. So I've activated my environment. I'm going to cd into my project and ls. Now the first thing we do is this line called pip freeze. And if we've seen pip freeze in the past, what does it do for us? Exactly. It's a little different than pip list. Pip list does the same thing for us. This is a human readable format. Pip freeze actually gives us what this could potentially read. If I put in this line, if I said pip install bcrypt double equals some version number, it's actually going to run that line and install that version number. So that's why we do pip freeze. We want all of our specific versions in a format that can be readable by Python, essentially. So when I'm in my project folder, I will pip freeze, and essentially I will freeze it to, and that's what an angular bracket does for me here. I'm writing to a file. I'm going to write to a file called requirements.txt in my project. And I can ls, and I can see, hey, I've got requirements.txt. Let me open up my editor of choice, and we can even see, what's this guy? Something else. Sorry, I'll just save that guy. All right, so this was our project from yesterday, and obviously the next demo, when we get to it, we'll be building on top of this. But this is our project from yesterday, and the only new thing is that suddenly we have a requirements.txt. And check it out. That was my pip freeze, right? So the platform will even tell you there's a couple known ones that will bug out. They're going to tell you if you have PyGraphViz or anything with MySQL that you want to remove those. So we just double check. PyTZ, PyParser. There's no SQL stuff. There shouldn't be. So we're looking good. These are our required packages. So then it's going to talk about creating a gitignore file. And what is a gitignore designed to do?
Ignore.
There you go. It basically tells our Git tracking system, which if I check right now, if I try to run a git status, this isn't a Git repository, so I'm good to go. But I can still create a .git ignore. And you'll want to do this before you start tracking, because you don't want to push those initial things and then try to reverse and take them out of the project, essentially. So touch.gitignore, and when I have that, I'll see, where is it? Yeah, that's okay. If I LSA, we'll see it generated right there. It's just a hidden file, so I can't see it. But in order to edit that file, I'll just open my inline editor, Vim. So if you use Nano, that's okay. Vim should be installed on your system, and it should be installed on the Linux system we deploy to as well. All that it is an inline text editor, essentially. So if I hit enter, Vim, this file, this is an editor, so I can just type. Now, Vim has some very specific rules about how we have to interact with it, and there are some directions in here. Namely, in order to start typing, I have to hit the word I, and suddenly you can see there's this insert. I can type to my heart's content, and when I'm done, escape. You can see the insert went away. And to save, :WQ. W for write, Q for quit. And these directions are in this deployment section as well, if you forget how to use Vim. One of the most popular questions on Stack Overflow is, how do I quit Vim? Because you can't just exit. You have to :Q, and if you don't change anything, it yells at you, :Q exclamation. And let's just make sure nothing's there. Okay, so what we're going to do with that gitignore file is essentially any extension or any file name I put in my gitignore, just like I just do a top down, top to bottom, any one of those things will not be tracked by my Git when I implement my Git tracking on this project. So say I have like a passwords.txt file. I don't want to put that on my repository. I want that to just be on my system. And later I'll generate it on another computer if I need it. I would put that in my gitignore, so that way I wouldn't push it to a repository accidentally. Now we put a couple things. We put essentially star.pyc. Does anyone know why we would do that?
Don't get any PYC files.
Exactly. All those PYC files were basically made for my system, not for the Linux system. So I don't want to push those up and have the Linux system think that those should run properly. So I'm going to ignore all my PYC files. I'm also going to ignore a venv, basically a virtual environment if it were in my project. There isn't one now in my project. We keep them separate. When we do get it to the deployed server, there actually will be one in the project. So that's why we put it in here now, so it never tracks. We never want that back. So let's go ahead and vim back in, I to type, star.pyc, and then the next line, venv /. So that's it for what I'm going to put in my gitignore, :WQ. And if I print that again, then I can see those two things. So my gitignore is set up properly. So now, git init, initialized an empty repo. If I run a git status, I'll see all my stuff, requirements.txt, all these other files, my gitignore file, but there shouldn't be any of my PYCs because we've properly ignored them. So git add -- all. Now git add -- all versus git add dot. Git add dot tracks from where you currently are down. Git add all, as in -- all, tracks everything regardless of where you are in the file structure within a Git repository. If you're at the top, you can do git add dot. If you do git add all, you won't get in trouble. Git status again. I'll see all of my things green, but notice no PYC files, just my PY files, which is awesome. Git commit -m, some initial commit. So nothing crazy, right? Just some initial commit message. So I got all that stuff. So I have now created a Git tracked project, and I've made one commit and essentially checkpointed my work. This is where the remote comes in. So the whole process is, what I want to do now is I want to essentially get my project from my computer to the deployed server. However, we don't just transfer it to the deployed server. It doesn't work that way. What we do is we stage it on a repository. Then when I access my deployed server, I connect to the repository and grab my code. So the way we use GitHub is this sort of middleman, or GitLab, I should say, this middleman between me and the server. There are ways that you can just do a direct, like FTP or some file transfer directly to the server. We don't do that just because in a normal working environment, GitHub is kind of the way you do it, or some Git repository, because that way we can all keep pushing to that, and then the server can just keep pulling from it when it needs to, like continuous integration. So we use the repo. It makes our lives a little bit easier. And in order to do that, do not copy paste this line. Do we think that this is our URL for our GitHub repo or GitLab repo? No. If you copy paste this line, just look at it. It's not us, right? We want to create a repository so that we can then connect to it. So new project, GitLab, my awesome name.
So I do that in GitLab?
GitLab, yeah. The directions say GitHub, but we're going to use GitLab. And I'll write it in gigantic letters on the board tomorrow. GitLab is what we want. Private repository on GitLab.
So we have to create our account on GitLab.
Exactly. This one you can create within a couple minutes. This one's no problem. But the AWS is the most important one. So project name, I always call my project name the same name as my actual project that was on my desktop or whatever. So record_haters. That keeps everything easier for me. This essentially would now get referred to as my repository name as record haters. And I'll explain why I do this in a couple of minutes. It'll be a little clearer. I don't have to do a description. I don't have to do anything else. It's private. Create project. So empty repository, that makes sense. For the first time you run Git, if you haven't already done so, it'll make you do this. It'll essentially ask you to set up your config. So you might have to run through these steps. I don't have to because I've already established that I'm going to connect here. Those are my credentials on my machine. But what we want to do is we essentially want to say we are going to git remote add our URL, git remote add origin, our URL.
Before you move on, if we've done the setting up the Git for GitHub, do we have to do it again?
You would have to change it for GitLab now. Yeah. Actually, as soon as it recognizes that it's a GitLab, you might have to do it the one time, but it's not going to change your global. It's not going to change your. Actually, no. Yeah, you will have to change it. You will have to change this from looking at the regular credentials that were the GitHub credentials versus the GitLab credentials. Yeah.
So then whenever we go back to GitHub,
Switch them back. Yeah. Yeah.
Unless they're the same username and user email.
Yeah. I mean, they could potentially be the exact same, and then you'd be okay. Yeah. So.
I kind of didn't understand what you guys were just talking about.
You'll have to configure your username and your email when you first establish your account here in order to connect to this properly.
Okay.
So you'll just have to basically run these lines.
Oh.
Yeah, just copy paste these lines in your terminal one at a time and then get to the next part of the deployment section. Cool? Cool. All right, so when we've done that, when we've set up our repository, when we've configured our usernames, we will run the line git remote add origin, which is connecting us to a remote. It's essentially connecting us to the repository. We've done this a couple times, I think. But then we put our URL in place of this guy. So we'll do our URL right here. And actually, these lines should show us git remote add origin, that exact line right there, right? recordhaters.git. And I can even just copy this and just throw a .git on the end of it. So git remote add origin, that .git. Just to kind of specify, we're calling on Git, we're connecting to a remote, we're adding one specifically, we're going to name it origin, and its URL, its location is essentially this URL, .git. So let's go ahead and do that, and looks like nothing happened, but we can check it out. We can say git remote, we can say, hey, we have a remote called origin, we can say git remote-v, and we can see exactly what origin is, what it's connected to. It's connected to my repository. So we say git push origin master to essentially get our project to push up to this repository now. And you'll see it take a little bit of time. Your computer might go slow, might go fast. But if we refresh this page, hey, suddenly we have our project here. Now notice, I did my git init inside of my project folder, right? When I do that, it's tracking everything from that location down. But since I'm inside of my project folder, I don't actually have my project folder name anymore, right? If you notice, I have apps, record headers, and all my files, but I don't actually see the project folder. Now later when we retrieve this, my repo name is record headers, and when I clone this project, it essentially creates that folder, record headers, based on my repo name. So just be aware that when you get a init inside of your project, you'll essentially lose that top folder. But then your repository name is now the folder that's going to contain everything when we clone it later on. So that's why I always name it the same. It effectively, keeps everything in line for me. So once we've pushed our project here, we can see we've got our requirements.txt. We should have all of our code. We don't see any of our PYC files, which is awesome. Right, everything's just PY. We're looking good. We're looking good. So now the next step is we pushed origin master. The next step is to start to set up our AWS EC2 instance. So right now, if you needed to envision what's happening is our project is essentially stored on the repository waiting for us to bring it somewhere else. We haven't done anything with deployment yet. All we've done is staged our project essentially. We'll hop into EC2. And if you're just at the Amazon dashboard, you'll see that there are some options. EC2 should come up here. Usually it's there. If you can't find it, just search EC2, and that's our software that we're using to deploy. It essentially is some virtualization software that's going to run on Amazon servers and just give us a small little computer that's going to be a Linux machine. That's what we're running our application on. And we use EC2 because it's very flexible. You can do a lot with it. It's a very powerful solution. Obviously, the way we're teaching it, it's a little cordoned off, right? We're saying follow these steps and do it this way, and it'll work. But ultimately, if this is something that you're interested in, DevOps, which is what this encompasses essentially, if this is something you're interested in, take a deep dive, figure out what gUnicorn's doing, figure out what Nginx is doing. A lot of these technologies, we'll kind of gloss over them, but they are all working together to keep our application running. There are turnkey solutions out there. There's a lot of people talk about Heroku, people talk about like GitHub Pages. There are things that are a lot easier to deploy on, but this will give you a bit of a better understanding of what deployment actually means, right? There's still software that's running your application somewhere, but this gives you a bit more control over it, and when you understand what's going on, you can do all sorts of wild things, like throw some load balancers on there to basically shift your load to different servers. You can throw some different elastic IPs to change your IP address if you needed to. So we'll kind of follow the platform and its implementation of our EC2 deployment. So we'll click Launch Instance, and you're going to have a couple options here. I'm going to zoom out just for a second so we can see all the options. So we have quite a few flavors of servers. We can get some Windows servers, we can get some Linux servers. A lot of these are flavors of Linux. What we deploy on is Ubuntu 16.04. So you should see it right near the top, like the fifth one down, Ubuntu 16.04. And double check, because this information is always listed right here. So EC2 is where we're at. We're launching an instance, Ubuntu 16.04. That's the version number that we're using. So back to our 16.04. Go ahead and click Select. And you see we have this little free tier eligible. It's just telling you have X amount of hours each month that the service can run for free if you're running them one at a time and you're within that year. So it should be free for you guys. So that's the one we're going to click. And it's just saying micro. It's basically just the footprint of the server. It's a very small server. We don't need a lot, right? So review and launch. Or let's see, configure instance details. We don't need that. Review and launch, actually. We can go right there. So when we review and launch, it'll give us some information about what we've chosen. We have 16.04. We did the T2 micro option. One thing we want to do is we want to actually edit our security groups. Our security groups are essentially how we can communicate and how the server can communicate with the outside world. So, you hear TCP/IP or HTTP, HTTPS. We essentially set up the communication protocols that the server can use. So SSH is actually what we use to connect to it, to talk to it, essentially, to tunnel into the computer. HTTP and HTTPS are the protocols with which it just communicates normal web traffic, essentially. So we want SSH. We also want HTTP, HTTPS. So be very explicit right now. Make sure you're following along. When we see this, we're going to add a rule, and ultimately we're going to add an HTTP dropdown and an HTTPS dropdown. So let's do that. So back here, add a rule, let's go to HTTP and add another rule, HTTPS. Cool. And these ports should be the same, 80, 443, and 22 for the 3 protocols. But what will change is the source, essentially the source from which we can access these things. So if you refer back, 22, 80, 443, so the ports are all the same. SSH, we only want to be able to connect to it from our IP address. So we can go ahead and specify our IP or my IP. And then from the other two, we want anyone to be able to communicate, right? Not just our IP address, so anywhere. So it's always good to give it a once over. SSH, HTTP, HTTPS, 22, 80, 443, my IP, anywhere, anywhere. Let's see, 22, 80, 443, and TCP, and cool.
Isn't the HTTPS a secure one and you have to have a certificate or something?
Yeah, so I mean, even though we specify HTTPS, it won't actually be serving it with HTTPS. It'll still be serving it with HTTP. Those certificates are something that we don't quite get into here. But yeah, HTTPS is the newer, more secure protocol versus the HTTP protocol. But once we make sure that all these settings are exact, notice that this IP isn't just your computer's IP, but it's your computer's IP in this location right now. Which means that if you change locations and you were trying to work on the same deployed server, you'd actually have to reestablish the rule at that point or modify the rule to allow this new IP. So just be aware of that. If you start deployment here, finish it here, right? Or vice versa. If you start it at home, finish it at home. Ultimately, we can't swap back and forth unless you edit your security group. It's a protection thing. We want to make sure that from this location you connect to it, but no one else can connect to it. So once that's all configured properly, review and launch. And it's going to tell us basically just an overview of all of our rules again, HTTP, HTTPS, and launch. When we click launch, what it's going to actually ask us to do is essentially create or choose some type of key pair. And what this key is essentially our key that we can use to access or to tell the server that we should have access to communicate with it. So it's something called a PEM key, and you should store it somewhere very safe on your system, right? It should never be on your GitHub. It should never be anywhere in the project at all. It should be an altogether separate location on your computer, like some PEM keys folder. So in doing that, what we'll do is we'll say not choose an existing pair. I think I have some on here. We'll create a new key pair. We can give it a name called haters, and then we can download our PEM key. So we can download haters.pem, and what you'll want to do, it'll be in your downloads, but you'll want to immediately put it to a more secure location, like your desktop. So, for me, right, well, it'll work, but ultimately you want to have some PEM keys folder on your system somewhere secure. Then we finally, after we've downloaded our PEM key, launch our instances. And it's going to spin up our server and essentially launch it. If I go back to my AWS, back to my EC2, I'll see running instances 0, it should say pending, right? So we now have this server essentially spinning up, right? Again, it's virtualization. We didn't actually rent a Linux machine that Amazon has sitting there plugged in. We rented a tiny footprint of a huge server farm, that this now virtualization is running a small Linux VM, basically, a virtual machine for us. But now our server should be spun up, so now we have to start to basically bridge the gap between our repository and our server. So, and going back here, once we've established this, once we've got our PEM key, we are going to go and we're going to see blah, blah, blah running. It's not quite running. Hey, it's running now. Cool. It takes a minute or two to get spun up. Then when we've got it, we can give it a name too to kind of make our lives a little bit easier. So name, we're going to call it Steven. And then once we have our server named Steven, we are good to go. So the next tab, or page I should say. Oh God, what did I do? So this is going to basically talk to us about how we can connect to the server. Because ultimately we still need to get our tech there. We need to get our application there. And we need to set up some daemons to keep the processes running properly. So a little weird, but what we want to do is we want to navigate to essentially wherever we kept that PEM key folder. Mine's on my desktop. So I will cd back to my desktop, ls, and I can see haters.pem. Now, if I go back to my instance click on it, and click connect, it's going to give me some information. Mac users might have to run this command, chmod 400, and what it's essentially doing is telling haters.pem that, hey, I have permission, I am the owner of this file. So you might have to run that, otherwise you'll get a little error. So when we're in the directory with our pem key, which is my desktop, which is wherever folder you put it, run that chmod. You won't see anything happen, but essentially we now have full permissions over this file. Once we've done that, it's going to tell you can do this, but ultimately this line down here is actually your full connect line that we can run. And what it's saying is saying to do an SSH connection, which if you remember in our security groups was one of the ways we said we could communicate. Do an SSH reading the haters.pem key as sort of my credentials, my access, and then connect specifically to this computer. Ubuntu at, and this is basically Amazon's way of determining, where this computer is in their domain. Windows users, you don't have a built-in SSH inside or SSH client inside of command prompt. Git bash does have an SSH. If you still want to really use command prompt, PuTTY is something that you can install and use with command prompt. And they have a nice little link for that right here. But if you're comfortable with it, I would just say use git bash for this, because that would be the easiest. It's built in, ready to go. You don't have to worry about any configuration. And really, this step forward is the only thing you'd actually have to do with git bash. Everything else you could have done in command prompt. So, cool?
I don't even know what git bash is.
Once you install Git, there's a git bash, which is like another shell that you can use, which just allows you to do like Linux-style commands. But it comes with a couple more features. It just looks like a command prompt, but it's different colors, and it gives you a couple different features built in. Yeah. Or you can download this PuTTY, and then that'll allow you to connect with your. I think Windows PowerShell actually has an SSH client in it as well. So if you use PowerShell, you're like all three of you, then you could do it that way also. But I suggest git bash is the easiest. You should have git bash. Yeah. So ultimately, once we've done a chmod, and this goes for both systems, we can actually run this command, SSH, and still within the same directory where our pem key lives, we can paste this. Now, something very peculiar about pasting into your terminal. If you have a trailing space, it will run the line as soon as you paste it. So if you had pasted with the intention of going back and editing something in that line and then entering it, just don't do that. Don't put something that you need to edit and paste it here, because you're opening yourself up to bugs. There are certain specific things we do that could really be bad. So if you are going to copy paste, I would paste into your text editor, just some other text editor, make the modifications, then copy that and paste it into your terminal. This one's not bad. We don't have to change anything, but you'll see shortly what I'm talking about. So, cool? So you'll see it'll ask you, are you sure you want to continue connecting? And we tell it yes. And when we see this green text come up, what I'm actually doing is this terminal is now actually accessing another computer. So it's as if I open a command prompt in an altogether new computer. Now, I had permissions because I had the pem key, and I told it this is my key to unlock my server. So now I'm essentially in. If I ls, I'll see nothing. I can cd up a level and ls, and I can see, hey, Ubuntu. So I'm in a completely different file structure at this point in time, and this will be Linux commands, FYI. Ubuntu is a flavor of Linux. Everyone with me? Cool. So we put it on our repo. We've now connected to our server. I haven't done anything else yet. Go ahead and close this little window out, little modal. And after we have connected, they're just telling us, hey, we are in this section. We're in this computer. Now, guys, please pay attention to what directory it looks like this is in when you're running the commands there, right? If you forget to cd up a level and you run a command and it doesn't work, just pay very close attention to what the command prompts are and where you need to be in your file structure when you run these things. But right now, top level, it's telling me to run sudo apt get update, which is a Linux command to essentially update this system for all of its regular packages. Blah, 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 blah. So it takes a minute. And be aware that this can even have key input lag because we're on another computer. So, I mean, my keystrokes are being sent to this computer and then printed on its terminal. So there will be a little bit of lag sometimes, depending on your connection. Now, sudo apt get install python pip. Let's do this. Sudo apt get install.
Why aren't you copying?
I don't know. Nginx. This one should be fine to not, or to copy paste as well.
Apt without a D.
Ah, it is. All right, and I can't spell. What's up?
Will this be anything different for me?
No, so this is all on another system now. This is all just Linux commands. So even if you're on a Windows user, you're still affecting a Linux.
Python 3 then.
Python 3, you should be able to do it the exact same way. I'll keep an eye out for any steps here. And if you do try to run through it today, call me over. Yeah, but I'm pretty sure you should be exactly the same. Because when we install Python, the only step you might have to take, yeah, we'll cross that. We'll work at it together when you do your deployment. Let me know when you want to do that. Sudo apt-get install. I'll try to deploy a Python 3 project ahead of you and see if I can run into anything funny. Sudo apt-get install Python pip, Python dev, Nginx, and Git, essentially some of the software that we'll be using. And it's just saying you're going to use X amount of space. Are you sure? Yes. And I mean, it can take a while sometimes. So a lot of packages. It's installing all of Python 2.7. Okay. Any day now. Steven, why is our server taking so long? You should know, man. It's your name.
Because it's linked to me and I'm sleepy right now.
Well, fair enough. Fair enough. Sudo apt get update again, just to update any of those packages if we need to. And it got some updates for us. Now sudo pip install virtual env. And now we have virtual env. So at this point, we're actually going to clone. And make sure you're still in your little home directory. The little tilde represents your home directory. We're going to clone our project. Again, do not clone annabanana.django courses. That's not our project. Clone our project. So git clone our project url.git. And username. And that's always fun. Check your credentials beforehand, because that can be really tedious, because you can't even see your password as you're typing it. But we're good. So if I ls now, hey, I got my project. I can cd in there, and I've got my project. So we have everything. So cool. Cd back up a level. Oh, I thought you had a question. We've cloned our project. It's just telling you that this is essentially what your directory looks like. We're in the Ubuntu folder, right? Remember we cd'd up a level. I saw Ubuntu. I went back in. We're in the Ubuntu folder, and I can see my repo name that has its apps, project, etc., right? So down here, we're actually going to make a virtual environment, and then we're going to install the packages that are on our requirements.txt, all of the packages that we know work. So inside of our repository name, let's get in there. And once we're in there, we'll create a virtual env. Then, the same name that we get ignored before, because we don't want to pass this back to the repo ever. Virtual env venv, blah, 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 ls, and we can see venv there, source, venv, bin, activate. And just like when we're on our local machines, I'm in a virtual environment. Now, once we're in our environment, we pip install, and we're essentially reading from, oops, didn't mean to tab, the requirements.txt. That's what the R flag is doing. So it's going to go through and install my packages. One little bug that you might be able to fix is if you get a broken package, if it says this can install, you can actually edit your requirements.txt from within here and just remove the package that it says isn't working, right? Because chances are that was like a garbage package that you didn't need in the first place. Obviously it depends, but you shouldn't have any problem just installing the regular Django and bcrypt requirements. It's when you have a bunch of external nonsense that you get those issues. But you could potentially fix that. If I run pip list right now, then I can see, hey, all of my packages. Oh, that's funny. Linux prints it out differently. I can see all of my packages here. So pip install from the requirements.txt. We also have a pip install Django bcrypt extensions. What's that?
No.
Oh, I thought you raised your hand. All right. Pip install that as well. And successfully installed. Awesome. And pip install gunicorn lastly. Oh my goodness, guys. Sorry. Maybe I should just copy and paste. Gunicorn, right? G unicorn, green unicorn. I forget why it's called green unicorn, but someone just wanted to have fun. So we pip installed all of our required packages at this point. Now this slide is just some information about Vim, about how we can navigate Vim, about how we enter and exit Vim and save. Because the rest of it, we're essentially modifying files while we're in our deployed version. So you remember way back when settings.py said debug equals true? Well, we're going to set debug equal to false. And if you guys are hitting weird errors and you're pretty sure your server should be working, but you can't see this error, and if you start to get server error 500 at any point in time, you could actually go back, set your debug equal to true, reload your daemons, and then you actually could see your error. Because server error 500 just means you just had an error in your code. So it's something different. So you could probably fix that one. But for now, please pay close attention. Anytime you see these Jinja brackets, the doubles with your repo name, you are to replace the entire phrase, including the Jinja, including the double brackets, right? So when I say CD project name, I'm not going to CD Jinja project name. I'm going to CD my project name, CD record haters. So now I'm on the inner project name, essentially. My repo name, project name. From here, I can see my settings.py, and I'm actually going to affect those. Sudo vim settings.py. Now, this is just our settings file, right? We can see all of our things. We got to change a couple lines here. We're going to say debug is equal to false. We're going to say allowed hosts. It's actually a list of IP addresses that we're allowing to host our site, so it's going to be our Amazon IP address. And then all the way at the bottom, we'll basically create this line of static root that's going to talk about where our static files will live now that they're deployed. So again, in order to affect, Jesus, hold on a second. Shut up, TV. Okay, thank you. So to start typing, debug, let's go here, false. Don't just grab this code and copy it somewhere. There's specific lines we're targeting here, so make sure you read through. Debug is false. Allowed hosts is actually going to be our Amazon IP, your EC2 public IP. Note that we're taking away the curlies, but there's single quotes around this IP address. So everything has to be very particular. Your EC2 public IP is actually located here. Actually, we should be able to see it. Public IP 34.238.84.158. That's the one. And we'll paste it there. 34.238.84.158. So debug is now false. We have our allowed hosts. Then all the way at the bottom, we'll put that next line, which is our static root URL, essentially. You can copy this guy too. Static root. And paste that right there. So that's it as far as the changes that we need to make to settings.py. Debug is equal to false, allowed hosts, and making the static root so that we know where our root or static files will actually get dumped. Escape to finish editing, :WQ to write and quit. So just to make sure, I can cat settings.py, which just allows me to read it. And hey, I got the static root there. We can make sure everything took. Yeah, I got my IP and debug false. So we're looking good. Cat will just print standard out, so it just prints to your terminal window. All right. The next line we run is a Python manage py collect static. Remember when I told you guys the reason that we actually look? So check it out. It didn't tell you to CD. Let's see, CD up a level. Now we can Python manage py collect static. Remember I told you before that when we do direct paths, like if I did absolute paths in my URLs, or not my URLs, but like my my static things, like my JavaScript or CSS, that would work for now, but when we deploy it would actually be different. The collect static essentially takes all our static and dumps it into that root that we just created. So that's where it will fetch it from when it needs to, which is why the Jinja is what actually goes and generates the paths and retrieves it when it needs to. So it's important that you do things the Pythonic way or the Django way of actually establishing the Jinja location of this specific resource. So we collected our static. You'll notice, hey, we dumped a bunch of files into that, into that location, header-static. Now we can next arrow. And it's going to tell us, all right, now it's going to start to set up the process manager that is gUnicorn, which helps our server essentially just keep running. In conjunction with Nginx, it keeps our server running and also handles the requests that hit this server. then transfers it or talks to the logic unit. So we can run this line gunicorn bind, but you have to make sure you're in the proper location. In my repo name, so the top level of my repo name, I can run this because it's talking about my project named .WSGI application. So this is, again, one of those times where maybe you don't want to copy paste this one. It won't break, but it just won't work properly if you just copy paste as it stands. -- bind 0000 8000. And our project name is also record haters and .WSGI as an application. Now, what it's essentially looking for, this would be us manually starting the process manager. This is us essentially saying, hey, go ahead and run. We're establishing that there's going to be a process that's continuing to run, but there's nothing to kick it back and keep it running right now. It's just us saying essentially run server, right? It's not the same exact thing. So this is really just a test, this first line. If we get this printout, this booting worker with PID 8700 or whatever 87, PID is just a process ID, so it'll vary. If we get this printout, that means that it worked properly. If you didn't get this printout, check where you are in your file structure. Check if you actually put your project name here, .WSGI application. Because that WSGI, remember way back when I mentioned what WSGI was, is this web server gateway interface. It's what glues our web server to our logic unit. So that's what we're saying. gunicorn is going to be that web server now, and it's going to connect to our logic unit. So once this is confirmed that you have this printout, you can shut down the process with Control-C. Let's clear it up so you get a little bit cleaner. And then we're ready to go. Control-C, now deactivate our environment. All right, no more environments. Now it's saying in our repo name, it's just talking about your structure is going to look like this, but we're going to make a couple changes. In our repo, we will sudo vim, and this will actually take us all the way back up to the root route, /, right? Starting at /, we go to etc systemd systemgunicorn.service. This will create a new file for us called g.gunicorn_service or gunicorn.service. That's essentially the service file that keeps that last process we just did, it keeps it running. So sudo vim this and paste it right there. Boom, new file. It doesn't exist. We're generating it right now way up at the top of our directory, essentially. Not even in our project anymore, just in Linux in general. And we're going to copy some stuff into this, but again, we have these Jinja brackets, so we need to make sure we're swapping every mention. Repo name, we've got repo name, project name, we've got, I think that's it. So in here, and again, the rules of Vim are nice and fun. I to insert, paste, and line by line we have to change it. So this is why it can be handy to do it inside of your editor of choice, because then you don't have to sit here and go line by line. Repo name, well, my repo name and my project name are the same, which is nice, record_haters, and repo name again here. And see, this is the same line we just ran, the workers3 bind, and we bound it to 000. That's essentially the same thing. We're just saying, hey, set up a process to keep this thing going now. All right, .sock. Notice none of these so far is app name. It's project, or repo, right? So if you name your project and your repo the same name, it's kind of nice. You don't have to worry about it. If there's a space, leave the space. Just FYI, don't remove that. I've seen people do that before too. And then give it a once and twice over, honestly, because you're probably going to miss one. I miss one too. So home Ubuntu record haters, that makes sense. You can start to actually see the directory and how it's working. So the working directory is my project. Then I'm executing at start home Ubuntu record haters, calling on the virtual environment, telling it to run the gunicorn that lives there, starting 3 workers and binding them on this location's .sock, which is essentially our web connection. And then it's saying, hey, it's going to run it as a WSGI application. If you don't get it, trust me, it's pretty weird stuff, so don't sweat it, but just understand that you have to do these steps exactly. All right, so looks good. and escape:/WQ, and we're good. And then something I always like to do just to make sure everything took is I will copy this directory, and you can always use that cat command to check it out. And it's looking good. Looks like we have everything there. It printed out, it saved that file properly. So, my repo name, blah, it's just giving me more information about specifically which names to use. Again, be extremely explicit and careful. Now we're going to set up, essentially, we're telling the system to keep this service file that we just created running. It's saying, hey, sudo systemctl daemon reload. We're going to reload all of our daemons. We're going to start gunicorn, and then we're going to enable gunicorn.
It looks like they CD'd up. Does that matter?
No, this is calling elsewhere, but yeah, they cd dot from above, yeah. But this should work for us. Created symly, because it's still referring to the system in general at this point. But good question. So it's saying we created a symlink from one location in our code to another location. This is almost like when you create a path variable. So it's saying that this file lives somewhere, and now we're essentially copying it elsewhere. So anytime you affect anything to do with gunicorn or your website, you have to redo these 3 steps. Just FYI. All right, so gunicorn's going, and let's honestly see if we can see anything right now if we go to our website. I know we can when we get Nginx spun up. Hey, all right, so it's not, don't get excited yet, but it's not broken yet, which is also a good sign. So Nginx is spun, gunicorn is set up, but we haven't swapped out an Nginx project, which is essentially what we're about to do. So again, we're going to sudo vim to a specific location. So sudo vim, and we're back at the root etc/nginx/sites available /project name, which is record_haters. Looks good. Sudo vim, cool. And again, a new file. And with this new file, we're going to copy this bit. And this is just a similar file to the gunicorn, essentially just saying, hey, this is going to be the server information. This is going to help gunicorn and Nginx communicate together. Now, when we're editing this guy, heads up, because this IP instance, or this place where we put the IP address, has no quotes around it. It's a little different than when we did it to settings.py. So let's go ahead and copy my URL real quick, because we'll need to do that. Backspace your EC2 public IP, paste it. Oh, that's not what I wanted at all. Ah, see? So we can't always just copy and paste. That was odd. It still took the HTTP even though it wasn't there. Interesting. All right, so paste it there. There we go, just the IP. Double check everything else. Do we look good? Is there any other double curlies? There's a bunch. So don't be deceived. Don't think that you're finished, right? My repo name, record_haters, and my repo name, a single typo, and this will not work. So please double check, triple check. All right, double check server name. Then we're going to root as home Ubuntu record haters, pretty much the working directory that was on the gunicorn. Proxy pass home Ubuntu record haters.sock. That's what we're proxying. We're allowing that to communicate for us. You just gotta follow. It's scary. I know it's scary, but trust me. If you guys follow these steps, you will not mess it up.
How am I ever gonna remember this?
It's literally, if you read that whole section, that's it.
No, I mean like
In real
10
life?
years.
Oh yeah.
Well, the video will be up, so.
Well, see, the beautiful thing is, even as full stack developers, chances are you're not going to be the guy deploying. So DevOps is an entire career in and of itself. They do not want you to touch the deployed version ever, honestly. Like, that is the live working version, right? So not to say you shouldn't know this stuff. And if you do enjoy DevOps, I mean, AWS, they offer a lot of courses. You can dig real deep into this stuff, because this gets into how the internet works, essentially, which is still, we're abstracted a couple layers from it for the most part, right? But this stuff, it is neat, but at the end of the day, you can get by with just being able to follow these steps, and then slowly, you know, as you start to repeat it more and more, then you start to go like, what is gunicorn actually doing? What is Nginx actually doing? But like anything else, when you first see it, it's pretty scary. It's like, what is happening? It's a lot of stuff, yeah. I'd say that. All right, so let's just double check that guy, make sure we're looking good, blah, blah, blah. Looks good. Okay, so back to the Nginx section. We're now going to do this little weird line that'll, a moment ago we created a symlink between two locations in our directory. We're going to essentially do the same thing where we're telling Nginx that, hey, this is a site that's available to you, my application. So that's what this next line does. This sudo ln, let's just go up a level, shouldn't matter anyways, but sudo ln s and /etc/nginx/ sites available / project name being record _ haters space /etc/nginx/ sites enabled. All right, so let's double check. Sudo ln -s etc nginx sites available, my project name, space /etc nginx sites enabled. All right, sudo nginx t to test. That's okay. Looks like it's successful. All right, we're almost there, guys. We just have to restart. Sudo rm, if we look right now, this is our site enabled essentially. We're just about to remove that. So we're going to sudo rm sites enabled, default. We can copy that line. Let's see if I can get it to go with the, I was going to try to get the space on there. Sudo rm, that thing, we're removing this. And we want to restart. Sudo service nginx restart. All right. So you guys ready for the moment of truth? Hey, so we are deployed. So
It only took 40 minutes.
it takes a while. So please go through it today. What's up?
So you're saying to put almost like 1/5 of the test into deploying for a point? You're telling us to, the exam is like 4.5 hours?
In other words, he's gonna skip deployment.
No,
I don't care what you do tomorrow.
Yeah, no, I'm not gonna skip the clock. I'm just saying. So you're expecting every single one, if they want to go for the highest point,
Mhm.
to only spend around 3 to 3.5 hours on that.